Yeah, there are 2 points of the door. That's the door, for example, and that is the handle of the door. This side of the door is fixed. Okay.
Yes.
So you can open or close the door. So this is the distance from the handle to the fixed point, and this fixed point is known as pivot point.
Pivot.
Yeah, exactly. Pivot point. And this point where you apply the force. Okay. This is called turning point. This is called turning point. It's fine. You apply the force here with that distance d, and this door turn clockwise or it is move anti-clockwise. It's fine, Heather. Yeah, Heather.
Yes, sir.
Yes,
So
sir.
so it means for kindly write, okay, for producing turning effect, the two things are the followings are very important. Following points are important. What are the following points? Number one, the distance between,
Sir, we can say that distance from the pivot.
yeah, distance from the pivot or distance between the pivot point or and movable point. Okay.
Okay.
So you can say also distance from the pivot. You can also say like that. Okay. Which is
Okay.
denoted by small d. The second thing, the force applied on the moving point, movable point. It's fine. And the third point is that the angle between force and distance must be 90. 90 means they are perpendicular to each other. It's fine. So they will be
Yes.
perpendicular to each other. Then your things is going to turn. Okay? Yeah, Heather.
Okay.
Yeah, Heather.
Yes, sir.
Can you repeat the points, Heather?
Distance between pivot and the movable and movable what? Yeah,
Movable
Point.
and the movable
point.
pivot movable
Movable
point.
point. Okay. Yeah.
The force applied on the movable point.
Yeah.
The the angle at the angle between force and distance must be 90 degrees
Ex-
perpendicular.
Exactly. Then your turning effect will be produced, and this movement of force, it is called turning effect is called movement of force. What is movement of force? Movement of force is
Turning effect.
turning
Yeah, sir.
effect of an object due to force. It's fine. So the
So what is movement of force? Yeah.
yeah, movement of force is a basically turning effect, and that is written in some books torque. Have you heard about the torque?
No.
Okay, this is the basically movement of force. Movement. It is called movement.
Okay.
Okay, it is called movement. Leave the movement of force. You can call them movement only. You can call them movement. Okay.
Okay.
Leave the torque. Don't call them torque. Called movement. What is movement? Movement is a turning effect.
The effect of an object.
Yeah, effect of an object is called. And the mathematical formula for the movement is force into distance. It's fine.
Yes.
So, so movement is equal to force into d. Now, this is the formula of the movement. Yeah, have you understand it?
Yes, sir.
Any question up to that point?
No.
Yeah, Heather.
No questions, sir.
Okay. So Heather, focus on the lecture, okay?
Okay, sir.
Okay. Now, for example, I write it that movement is equal to force into distance. So it means if I give you force and if I give you distance, you can find the movement, okay?
Moment. Okay.
Now, let's talk about the unit. We know that force is equal to Newton and distance is equal to meter. So
Newton
that's
meter.
why, yeah, movement is Newton
Newton meter.
meter. It's fine.
Yes.
Another point, the movement is vector quantity. Remember, okay? The
Okay.
movement is vector quantity. So it means movement have the direction. So the point should be rated that the movement has two direction. Either it can be clockwise or it can be anti-clockwise. It's fine.
Yes.
In some book, anti-clockwise word is replaced by counterclockwise. Okay.
Okay.
Yeah. And some teachers using the word of counterclockwise. Now, if I give you the force that is 10 Newton and I give you the distance that is 2 meter, can you calculate the movement?
Yes.
What will be the
20.
movement?
20.
20.
20
That's
Newton
correct.
meter.
20 Newton meter. Yeah, Heather. Have you got it?
Yes, sir.
Yes.
Okay. Now, there is very important topic related to movement that is called principle of movement. That's
Principle
very
of movement. Yes.
important. Okay. The mostly the question is
Okay.
coming on this topic. Okay.
Okay.
Principle of movement. Now, what the principle of movement tells us? Principle of movement tells us that sum of clockwise,
Moment should be equal to the anti-clockwise moment.
yeah, sum of the clockwise movements is
Should
equal
be equal
to
to the total anti-clockwise moment.
sum of anti-clockwise or counterclockwise
Okay.
clockwise movement. Yeah, Heather. Can you repeat the definition of principle of movement?
Okay, sir. Sum of clockwise moment is equal to the sum of the anti-clockwise moment.
Yeah, exactly. Counterclockwise or anti-clockwise. Let's consider the example. Let's consider an example of seesaw, okay?
Okay.
This is a seesaw. Its center point is O. Now the one child is sitting here on the seesaw, okay, 8 point A. And the other child is sitting on the other side of the seesaw, okay, and it is 8B point. That's fine.
Yes.
Now the center point is O now. Now the weight of the child A is, for example, W1, and the weight of the child B
W2.
is W2. The distance of the child A from the center is D1. The distance of the child 2 from child B from the center is D2. Then how we will write the principle of movement? Now, if you see here, this is my clockwise, and this direction is my anti-clockwise. It's fine.
Yeah. Yes.
So then I will write the formula that sum of,
Anti-clockwise is equal to clockwise.
yeah, sum of the clockwise movement will be equal to sum of the anti-clockwise movement. It's fine, Heather? Yeah, Heather?
Yes, sir.
Any question? Have you understand it? Yeah,
Yes, sir. Clear, clear.
yeah. Now you will write that W1 into D1 will be
Is equal to
equal to
W2
W2 into
D2.
D2. So this formula is regularly coming into paper. So out of three quantities were given to you. You will find the fourth quantity. Okay, it's fine. So this is
Yes.
your principle of movement. Have you noted that?
Yes, done.
Okay. Heather, any question, beta?
No question, sir.
Okay. Have you noted, Heather?
Yes, sir.
Okay. Now moving toward the syllabus, let's see the syllabus now. Okay, if you see the syllabi, we have discussed the point one, that is the from the everyday life. We have take the example of door. You can take the example of window. Okay,
Of
these
a
were,
fan.
yeah, sorry,
Of a fan. Fan.
and any example.
Clock.
Yeah, clock is also there. So these are the examples of everyday life. The second, they have written the definition. What is movement? Movement is a force into perpendicular distance. Kindly note this point, okay? Heather,
Okay.
can you read that point? That I'm going to underline it.
Okay.
Yeah.
Um, moment is force into perpendicular distance
Just, just, just that.
from the pivot.
Yeah,
From
just
the
that.
pivot.
Just that perpendicular distance. So remember that force
Okay.
is always, kindly note that point, okay? In movement means in turning effect, force is always perpendicular. It's fine. Perpendicular to distance.
Yes.
Okay,
From the
and
pivot.
distance is from the pivot point. Then we have
Okay.
discussed the principle of movement. The principle of movement. Okay. And
Yes.
then we have discussed the application, this fifth point, how to apply the principle of movement. Now, coming toward the equilibrium.
Okay.
Now, what is equilibrium? That when, kindly write
Sir,
that
the
when,
sir, so can I tell?
yeah, yeah,
Sir, the sum of the force in one of the direction equal the sum of the force in the opposite direction.
yeah, that's also fine. But you can also write that sum of the
The
movement
law of okay,
is equal to zero. Okay,
okay,
okay. Let's discuss in different way, Heather. Ahad, I think you are
okay,
little bit going to confuse. So to avoid that confusion, let's first discuss the equilibrium. Okay.
uh,
Okay. What is equilibrium? Equilibrium. So equilibrium means that the object is balance. Okay. So
okay,
means resultant force on an object is zero. So means the object will not accelerate. It's fine.
yes,
So another point, the object either at rest or moving with constant speed, or you can say velocity. Okay,
okay,
it's fine. So these are the points for the equilibrium. So under these points,
yes,
we have the two conditions of equilibrium. Okay, we have the two
yes.
conditions of equilibrium. Two conditions. Two conditions. Number one, that first condition.
So can the
Yeah.
law of moment apply?
No, that's about the forces that you tell me before that sum of all forces, sum of all forces is equal to zero. Fine. So means the resultant force is zero. Force is zero. It's fine. Yeah. Ahad.
Yes,
Okay. Heather, it's fine.
Yes, sir. Clear.
Okay. The second condition. Yeah. Now can you tell me, Ahad, what is the second condition? Okay. Write the second condition that sum of all
sir.
movement.
The law of moment apply.
Law of, sorry, what?
Moment apply.
Yeah, law of movements apply. So sum of all movement is equal to zero means where principle of movement is applied. Okay. So again, resultant movement is zero. Resultant movement is zero. That's fine. So this is the second condition of equilibrium. Yeah. Have you noted these conditions?
Yes, sir. Wait, wait.